Hi, my name is Taylor Bidone. For some reason, my last video just cut off while I was in the middle of it, but this is my chemistry video assignment for Chemistry 101. This is my student ID, and I'm in Andover, Minnesota, or we're right next to Blaine, so that's why it says that. It's 0 degrees Celsius, 30.11 on the barometer. Now, I wrote down the question, so I'm going to read it first. Imagine you are running the same experiment for the thermal decomposition of mercury dioxide to collect oxygen gas over water in a laboratory in Andover, Minnesota, where I am. When completed, you collected 34.3 milliliters of oxygen gas by water displacement. Determine the amount of mercury dioxide used in this reaction. So, I already started this, it just cut off my video. So first I wrote the balanced equation. As you can see, I had to add the 2 in front of the original mercury dioxide, and then added 2 in front of mercury to balance the equation. And our knowns are the volume of oxygen gas at the end is 34.3 milliliters. The temperature is 0 degrees Celsius. Hold on, let me close that door. My family's kind of loud. Sorry about that. So 0 degrees Celsius, which is 273 degrees Kelvin, and 30.11 IN for the pressure. So what we need to do to get that into atmospheres is divide that by 29.92. So I'm just going to put that in my calculator. And the only number we were given was the milliliters, which had 3 significant figures, so we're going to try to keep 3 significant figures throughout. So 30.11 divided by 29.92 equals 1.006. So we're just going to keep it to 3 significant figures, so 1.00 atmospheres, or 0.1 atmospheres, 1.01 atmospheres. So right now, our workbook looks like this. The last thing that we need is our vapor pressure. So I did look, but I'm gonna need to look again. It's 4.6 torr. Yeah, it's 4.6 torr for 0 degrees Celsius for the vapor pressure. Okay, so now that we have our nose, we have our balanced equation, what we need to find next is the amount of moles. So that equation is going to look like this. So N over volume times pressure, or N equals volume times pressure over RT. And our R is obviously 0.0821. So let's just plug in those numbers. So that's going to look like, I missed an important step. We gotta subtract our vapor pressure from our total pressure to get our partial pressure. So 4.6 torr times 760 is going to equal the amount, or divided by 760 is going to equal the amount of atmospheres. That is 4.6 divided by 760 equals, and this is a calculator, 0.006. So 0.006 minus 1.01, 1.01 minus 0.006 equals 1.004, but we are going to keep it 3 significant figures, so we're going to round to 1 again. Kind of makes it easy. So our volume, 34.3. Oh, there's another thing I missed. We need liters, so 34.3 times 1,000 is, or divided by 1,000. 34.3 divided by 1,000 equals 0.0343. So 0.0343. Okay. Times 1 atmosphere over, I'll let you see what I'm doing here, 0.0821 times our temperature, which is 273 degrees Kelvin. So I'm just going to plug, I don't know how well you can see it, but I'm going to plug that into my calculator and we will get the amount of moles. So 0.0. So we got this, 22.4, all right. That's not the answer. Duh. Okay, 22.4 is just the bottom, and now we want to divide our volume times our pressure by that. So the answer we get with 3 significant figures is 1.53 times 10 to the negative third. So this is our moles that we got. All right, now we want to convert that to the amount of mercury we started with. All right, so that equation is going to look like this. I'm going to start with a fresh page. So N times our mole ratio, so that's mole, so that's going to be 2 mercuries for every 1 oxygen times 1 over our molar mass, and our molar mass is going to be 232.59. I added that up before I recorded. So we're just gonna add the number from before. So 1.53 times 10 to the negative third. 1.53 third moles of MgO times 2 mg for every O times 1 over 32.59 molar mass, so grams, 1 mole. Okay, so this is what our equation looks like now. So I'm going to plug that in to my calculator. So 0. 0. Kind of got a little crazy number, so I'm gonna replug that in. It's a really old calculator, so just 'Yeah, that looks more normal. So we have 0.00430 if we're rounding to the significant figure. So 0.00430 milliliters or liters. So we can times that by 1,000, and let me times that by 1,000 on here, and it's 4.3 milliliters of mercury. Where is it? Oh, yeah, right there. 4.3 milliliters of mercury. Thank you.